Imagine you're localizing the user interface for a highly confidential, unreleased virtual reality headset. You know, the real high stakes, market defining stuff. You've got the technical specs, the proprietary spatial mapping features, and the entire marketing narrative for a device that won't even be announced for another 6 months. And then you hit a tricky phrase, so you run a quick section through a free public AI translation tool just to get a baseline. It happens all the time, right? But without realizing it, you've just handed over your client's most guarded intellectual property to a global open beta set. It's gone. You have effectively leaked the product before it's even announced. That single click, made purely out of convenience, could cost a company millions in lost competitive advantage and destroy your professional reputation overnight. It really is the ultimate nightmare scenario. And the truly terrifying part isn't some shadowy hacker breaking into your mainframe. No, it's the banality of it. It's one simple copy-paste command executed by a well-meaning professional who fundamentally misunderstands the architecture of the tools they're using. The damage is instantaneous, and from a cryptographic standpoint, it's completely irreversible. If you're operating in the trenches of the language services industry, you already know the stakes have never been higher. This is Locanucu, localization news you can use. What we are seeing in the industry right now is that our true currency has evolved dramatically. It's no longer just about linguistic accuracy. The real currency today is data security, privacy, and absolute asset protection. That is the tectonic shift we are standing in the middle of. For decades, the localization world was completely obsessed with the output, analyzing the translated word, the cultural nuance, the final polished string. But today, our focus has violently shifted to the input, specifically how that source data is guarded, how it's ingested, and who fundamentally owns the mathematical representation of your language data once it actually enters a neural network. Let's start right there with the concept of ownership, because there is this pervasive myth floating around right now, a sort of collective delusion, really. It's this idea that we've all been handed these miraculous, cost-free public AI tools to just accelerate our workflows like a gift. But we have to look at the underlying mechanics. When you dump a highly curated translation memory or a proprietary term base into a public large language model, what is actually happening under the hood? Well, to understand that, you really have to stop thinking of these public AI tools as software applications and start thinking of them as massive, continuously evolving mathematical oceans. When you delegate your localized assets to an unsecured external AI provider, you aren't just letting a machine read your text. You are fundamentally altering the probability weights of that model. Large language models, at their core, are just prediction engines guessing the next word. They map relationships between words, what we call tokens, in a high-dimensional vector space. So if you upload your proprietary glossary for, say, a next-generation surgical robotics platform, terms you've spent months researching and mapping across 20 different languages, you're essentially handing over the coordinates to your intellectual property. You are giving away the map. The engine analyzes your specific, highly valuable pairings of source and target terminology and breaks them down into vector embeddings. Your proprietary knowledge literally becomes part of the engine's future prediction capabilities for everybody else. The payment for using these supposedly free tools is invisible, but it is exorbitant because you are paying with your competitive moat. Now, I know some of you might push back and say that these providers claim they don't use our data if we use their enterprise API. That's a crucial distinction, but it's exactly where the danger lies. The ambiguity of the user interface versus the harsh reality of the terms of service. Yes, some API agreements state they have zero data retention policies. But let's be real. The everyday freelance linguist or project manager isn't usually spinning up a secure, authenticated API connection with a bearer token and isolated server architecture. They are using the public web interface. They are downloading browser extensions that promise to translate your screen instantly. And in those public environments, your data is absolute fair game. It's scraped, aggregated, and fed right back into the foundational model. It's basically like hiring a brilliant free intern to organize your company's deepest financial secrets. But the catch is is they get to publish a book about everything they learned when they leave. And not only do they publish the book, but they offer that exact recipe to your rival the next time they walk into the lab and say, hey, I'm trying to engineer an electric vehicle battery with the exact same range as this. The AI will statistically favor your terminology because it's high quality, curated human data. It loves your data because it's better than the garbage it scrapes off the internet. This is why our advice is uncompromising. The absolute non-negotiable baseline of modern localization has to be that the data is yours and only yours. You must establish walled gardens. A walled garden, in this context, refers to a closed-loop system, typically utilizing a single-tenant cloud architecture or an isolated virtual private cloud environment. It is mathematically fenced off from the public internet and public models. In these enterprise-grade ecosystems tailored for the language industry, the AI model is isolated. When you feed it your translation memories, it utilizes a framework called RAG, Retrieval Augmented Generation. To break that down simply, RAG allows the model to temporarily retrieve your specific proprietary data to inform its translation, but that data never ever updates the base model's weights. It's referencing your proprietary dictionary to do the job, but it's not memorizing the dictionary and taking it home. This makes your personalized environment incredibly attuned to your specific brand voice, while a hard mathematical barrier prevents that data from bleeding out into the public sphere. Your intellectual property remains an asset on your balance sheet, keeping your competitive advantage completely intact. But if we establish that we need this closed-loop architecture, we still have to deal with the messy physical reality of the industry. Localization is highly dynamic. We have massive data packages flying from a vendor in Seoul to a reviewer in Munich and then to a linguist in São Paulo, all day, every day. How do we lock the doors when the data is constantly moving? This is where we transition from data ownership to cryptographic infrastructure. Safe localization requires two non-negotiable pillars: encryption at rest and encryption in transit. Let's dig into the math of it. A lot of people assume that if their computer has a password, their data is encrypted. That is a fatal misconception. A password just protects the front door of the operating system. If a malicious actor bypasses the OS login by physically taking the hard drive, they have direct access to the raw files. Encryption at rest means the data itself, while sitting idle on a server or a hard drive, is scrambled into a chaotic puzzle using advanced cryptographic algorithms. The industry standard right now is AES 256. To brute force a 256-bit key with current classical computing technology would take longer than the current age of the universe. It is mathematically unbreakable by brute force. So even if your cloud server is completely compromised and terabytes of translation memories are exfiltrated, all the attackers get is digital noise. That covers data sitting on the server. But what happens when that data has to move? What happens when you hit send? That is encryption in transit, and it's arguably where the industry is most vulnerable right now. When data travels across the internet, it passes through dozens of nodes, routers, and servers. If it isn't encrypted using protocols like TLS 1.3, transport layer security, which creates a secure, mathematically locked tunnel, anyone sitting on those nodes can read the packets in plain text. Let's apply this to a real-world scenario. A massive amount of localization work is still, terrifyingly, done via standard email attachments. A standard email attachment is a massive liability, even with major providers, because the email usually sits unencrypted at rest on the mail server and bounces between multiple intermediary servers before reaching its destination. Sending a localized file containing proprietary client data via an unencrypted email is literally like writing a confidential schematic on a postcard and handing it to a courier. Anyone who handles that postcard along its global journey can just flip it over and read it. Imagine you are localizing phase 3 trial data for a breakthrough oncology drug. You have a team of linguists spread across 3 continents. If just one of them downloads a file over an open network at an airport lounge without end-to-end encryption, you are actively exposing patient data to anyone running a basic packet sniffer 2 seats over. In highly regulated fields, that kind of exposure is a catastrophic enterprise-ending event. It destroys trust and invites massive lawsuits. Now, the everyday linguist isn't a network security expert, and they shouldn't have to spend their mornings configuring public and private key pairs. That's the beauty of using purpose-built, secure platforms. The cryptography happens invisibly in the background. Your primary job is simply to enforce the discipline of staying inside the walled garden. You cannot download highly sensitive files to your local unencrypted hard drive or use consumer-grade file transfer websites just because a file is large. The centralized ecosystem protects you, but its mathematical armor is entirely useless if you intentionally carry the data outside its walls. The human element is always the vulnerability, and that naturally forces us to look beyond just the mathematical locks, because even with flawless AES 256 encryption, you still have to answer to international law. The regulatory landscape right now is incredibly unforgiving. If you are operating any cloud-based workflow today, you are legally bound by international data protection laws, most notably the GDPR and the newly minted EU AI Act. There is a lot of fatigue around GDPR, with people just thinking of annoying cookie consent banners. But that disconnect is dangerous. GDPR establishes that individuals own their personal data, demanding strict accountability for anyone who processes it. If it can identify a natural person, a name, an IP address, HR performance reviews, it is regulated data. Under GDPR, your client is the data controller, dictating how the data is used. You, the localization professional, are the data processor. You are legally required to guarantee the security of that data. If you take a sensitive HR document and run it through a free public AI tool to speed up your translation, you have just engaged an unauthorized subprocessor. You've stripped regulated data of its secure environment, violating international law. If that tool leaks, you are facing massive regulatory fines of up to 20 million euros or 4% of your global annual turnover. It will close your doors. And then we have the EU AI Act, which specifically targets generative AI. What makes this legislation precedent-setting is its risk-based approach. It categorizes AI systems from minimal to unacceptable risk. If you are using AI to help translate banner ads for a new line of sunglasses, that might fall under limited risk, primarily requiring you to disclose that AI was used. But consider the specialized text we handle. What if an AI model is dynamically translating flight control software for commercial drones, or the user interface for an automated insulin pump? If a flawed algorithm mistranslates a critical safety warning, hallucinating a negative into a positive, that is a high-risk failure where lives are on the line. The EU AI Act demands that anything in that high-risk category undergo rigorous conformity assessments, proving robust risk management, traceability, and, crucially, human oversight. You must prove there is a human in the loop, accountable for the final output. We aren't just linguistic converters anymore. We are the regulatory gatekeepers of critical global information. So the fortress is built. The walls are high. Now let's talk about actually operating inside that fortress and using AI to make our businesses better. This is where the narrative shifts from defensive paranoia to offensive capability. Once you have a secure, closed-loop environment, you can train enterprise AI engines to sound exactly like your clients. It feels like magic, but it is highly deliberate data engineering. Your translation memories and approved glossaries serve as the ground truth. Every single time a human linguist corrects the AI's output, that correction is captured and the system learns the nuance. However, there is a massive pitfall here. You must guard against what the industry has vividly dubbed AI slop, driven by a phenomenon called model collapse. Here's how it happens mechanically. If an AI model is continuously trained on data generated by other AI models, the statistical distribution of the language degrades over time. Humans provide the long tail of the distribution. We introduce creative, highly accurate terminology. AI, however, favors the highest probability path. It plays it safe. If you allow AI-generated text without rigorous human curation to be fed back into your training database, you create a statistical echo chamber. The rich, specialized vocabulary of your legal or medical text slowly morphs into bland, repetitive, homogenized slop. Think of training an enterprise AI like forging a high-grade titanium alloy. Your closed-loop system is the furnace. Your translation memory is the meticulously refined raw material. If you are sloppy and drop in cheap, unverified scrap metal, say a massive batch of unedited machine translations, you compromise the structural integrity of the entire batch. Suddenly, your highly professional technical manual starts sounding like generic nonsense. And because contamination in a vector database is notoriously difficult to isolate and remove, keeping absolute control over dataset quality is the ultimate form of asset protection. To prevent this, you have to implement smart AI review environments. In these workflows, the AI acts as an advanced drafting tool, but its suggestions are never automatically committed to your master translation memory. They are held in quarantine until a qualified human linguist reviews and validates the string. The human expert acts as the cryptographic and linguistic filter. Only when the human stamps it with approval does it influence future predictions, guaranteeing your AI continuously scales without suffering model collapse. Before we lock down the final takeaways to wrap up today's insights, just a reminder that you can find more deep dive strategies and foresight exactly like this at Locanucu.com to keep your operations bulletproof. So, how do we actually implement all of this safely on a Monday morning? How do we build a resilient AI strategy when the market is moving at light speed? The absolute first ironclad rule is this: never, ever deploy an AI strategy purely as a reaction to industry hype. You open LinkedIn and see someone claiming they localized a 100,000-word financial compliance audit in 15 minutes for $50. It creates this suffocating FOMO. But businesses that rush to test AI without a mathematically sound strategy will inevitably leak data, violate compliance laws, and generate massive amounts of slop that takes months of expensive human labor to untangle. The tactical alternative is iterability. You must run secure, scalable, highly isolated pilots. A pilot is a controlled scientific experiment focusing on one specific workflow or a low-risk language pair, designed in deep consultation with the linguists and engineers who actually touch the data. You gather empirical feedback, look for the cracks, tighten access controls, and run it again. Only when that single pilot is demonstrably flawless, secure, and compliant do you begin to scale it to other branches of the business. And when a client demands that you match the speed and price of some unsecured generative AI tool, you do not engage in a race to the bottom on price. If you do, you've already lost. Instead, you fundamentally change the product you are selling. You sell accountability. You look them in the eye and say, "We aren't just giving you translated words. We are giving you an ironclad guarantee that your proprietary product data will not be absorbed into a public model. We are shielding your board from multi-million euro regulatory fines under the GDPR and EU AI Act, and we are providing a mathematically encrypted ecosystem." You are selling a digital fortress. You explain that the human expert is the lead surgeon, and the AI is simply the advanced robotic armature. You wouldn't let an autonomous surgical robot operate without a highly trained lead surgeon in the room, regardless of how advanced the software is. The AI handles the high-volume, repetitive tasks, but the human expert navigates the unforeseen complications, interprets the complex regulatory environment, and is ultimately legally accountable for the safe outcome. And this was your industry update from Locanucu, localization news you can use. The biggest takeaway today is that AI won't replace your role. It makes your expertise infinitely more valuable, but only if you master the data security, privacy, and compliance that keep your assets completely under your control. The future of the localization expert isn't just about translating words. It's about acting as the highly specialized cryptographic guardian of a culture's digital privacy. Keep your data locked, keep your standards high, and we'll see you next time.